Hello and welcome. My name is Ines. I am a software engineer and project manager at YellowScan. In this video, I'm going to walk you through how to use YellowScan CloudStation, our powerful software designed to process LiDAR data collected with YellowScan systems. Whether you're new to LiDAR workflows or just need a refresher, I will guide you step by step from importing raw flight data all the way to generating final deliverables. Alright, so now I'm in the home page of the YellowScan CloudStation, and I'm just gonna go ahead and create a new project. So here I need to select a folder. The folder I need to select is the folder containing all my raw data, basically all the data that were extracted from the USB stick after the flight. In this case, I'm going to process a YellowScan Navigator flight, which is our bathymetric LiDAR system that has an embedded camera on it. So I'm just going to select the whole folder, and the YellowScan CloudStation is going to automatically detect that there is one Navigator flight, and I'm just going to validate this and click on create. Now what we see here is the trajectory of my whole flight. The colored lines are basically the straight lines. These are the lines we want to extract data from. So the CloudStation automatically pre-selects straight flight lines that are long enough. So now I can also, if I don't want to keep this line, for example, I can just click on it and press the delete button. I can also add different flight lines, and if I want to, I can also change the length of my flight lines. In this case, I have previously selected the flight lines I wanted to use. We're going to call them strips. So I can just import my timestamps that I have already or previously saved. And here you go. So now we can see all the flight lines that were selected, and basically the data are going to be extracted from these parts of the trajectory. But before launching the point cloud generation, we want to go through the trajectory refinement process. You have to know, a few years ago we had to go through a third-party software to refine the trajectory. The software depended on still depends on the IMU provider. So if you have an Applanix IMU, for example, you had to go through the Applanix postback software. If you had an SBG IMU, you had to go through the Technologia software. But that was pretty complex and time consuming. So we've integrated the whole process of the trajectory refinement within the CloudStation. So now if you want to generate your smooth best estimate of trajectory, commonly known as the SBET, you just right click on your flight and click on generate SBET. Alright, so like I said, we've integrated the whole trajectory refinement process within the CloudStation, and we tried to make it as easy as possible. So we broke it down to 3 easy steps. The first one is the payload configuration. It's basically where you enter your lever arms and the orientation of your scanner. We have several default presets that you can use, or if you have a special orientation, you can just click on custom and enter manually your mounting angles. So once you're done, you can save your preset and you can use it for other flights. Alright, we can move now to the second step, which is the GNSS mode selection. We have different GNSS modes depending on whether you're using an Applanix IMU or a SBG IMU. Here in the YellowScan Navigator, we have an SBG IMU, so we have the GNSS modes from Technologia software. We can choose Smart Process or PPP. And so the CloudStation will automatically select the best mode for you. If you have Rhinex files, the CloudStation would automatically find them and select them for you. In this case, I don't have one, so I'm just gonna stay with Smart Process, and click on next. So here we're at the last part of the trajectory refinement process. I can choose whether I want to export in ellipsoid height or orthometric, and once that's done, I can select my project CRS, which is the coordinate reference system. So you can choose from the list, and you can also search. So if I'm looking for the NAD 83, we have multiple ones, or you can just search by EPSG code. This will work also. And once I'm done, I'm just gonna click on process bed, and the CloudStation will launch the according software in the background, and you won't have to do anything. And once that's done, you can just apply your bed, and that will be it. In my case, I've already generated this bed. As you can see in the settings here, my bed has already been selected for my flight. So basically here, I just click on the yellow button, and I want to move to the point cloud generation. So in case of topographic LiDAR systems, clicking on this button will only launch the extraction, which is basically the generation of your point cloud. But since we're using a bathymetric LiDAR system, we have some setting up to do first. The first thing we want to do is set the detection sensitivity. So this is basically the higher you set it, the more points you will have on your point cloud, but it will also make the risk of seeing noise appear higher. So setting this parameter will only depend on the conditions of your flight, and you can test the three and select which one you want to keep. The second parameter is the water refractive index. This is basically a value that indicates the kind of water you're scanning. So for example, the default value that is set is 1.33, which is basically the default value for fresh water. And for example, 1.34 is the value for ocean water. I'm going to keep it to 133 and keep my sensitivity to medium. I'm just going to click on process, and now the CloudStation is going to extract echoes from the full wave data and then extract LiDAR points from these echoes. Once that's done, the CloudStation is going to classify all my points to what's water and what's not water, and we're just going to wait for it to finish. Okay, so now that it's done, the CloudStation is going to show me a first preview of my point cloud. What I want to do now is actually inspect my point cloud, and you can see the blue points are everything that's surface of the water. The yellow points are everything that's underwater, basically. Now this step is used to manually correct any mistakes that the classification could have done. For example, let's say these points here are not water, but I know for a fact they are water. So I can just right click on the point and say that's actually a water surface. In the meantime, I can also select a point that was classified as water when I know for a fact it was not. I can right click on it and say that's not water. And once I can add as many constraints like these as I want. Once I'm done and I'm happy with my selection, I can click on refresh, and the classification will run again, but this time it will take into account all the constraints I have added. In my case, I don't want to add any constraints because I'm pretty happy with the classification I have done. So I can just click on next, and now the CloudStation is going to correct the position of underwater points and the intensity of these points, and that will be it. And my point cloud is now ready to be inspected. I'm just gonna click on view point cloud. Okay, so now I have my point cloud generated and all the water points are classified. I'm just gonna hide this here and hide the trajectory. so I can inspect the whole point cloud. Okay, what I can do, I'm going to increase the point size. As you can see, we have a lot of vegetation around here, and we can see that we have this river. What I can do is create a slice to give you a better look at what's going on. I can open here, and here we go. So now what I can do, I'm gonna increase the size of my slice, and by clicking on Shift and using the mouse roll, I can just go through my point cloud, and I can see that the river here, we can see the surface and the bottom. What I can do is change the color of my points to the classification colors, and this will allow me to see that I have in blue the water surface and in yellow everything underwater. Now something good about LiDAR that you will never get with photogrammetry, for example, is, as you can see, we can see all the vegetation, but we also can see everything below it. Alright, I'm gonna keep scrolling through my point cloud, and here, for example, we can see that we have this point of water surface and this point of the bottom, and we can see in height we have 2 meters depth. Okay, now I'm gonna close this slice view, and I'm gonna keep inspecting my point cloud. So of course you can also colorize your point cloud by elevation. This will give you a better look at the terrain. I can also color by intensity. This will give us a better look at different light reflection levels of the trees. For example, you can see that these trees have a different intensity than these ones, and so on. So you can basically inspect your point cloud as you see fit, depending on your use case, of course. Now, let's say I am interested in my use case in the whole terrain, so the bottom of the water and everything that's beneath the trees, and I don't really need any of these trees in my use case. I can just go ahead and go to the terrain module right here. I'm gonna color by elevation again, so it's pretty. So the terrain module is basically a way to classify your point cloud to ground and non-ground. This will also classify your water points to detect what's actually the bottom of your river, for example, here. So the parameters are pretty simple and pretty straightforward. What you have to do is just click on classify, and you will get your classified point cloud. Alright, so now that I have classified my points, I'm going to show you immediately the result. When I select the classification color, you can see that we have new colors comparing to earlier when we only had white points and water points. So here, in everything that was colorized in orange has been classified as non-ground, which means if I go around here and select the filters, I can select to remove everything that is other than ground, which will give me a better look at the terrain. And like I was saying earlier, you will never get this kind of precision and access actually to the terrain with photogrammetry, for example. This is a very good example of why LiDAR is a powerful tool. So in addition to having classified everything topographic, we've also classified everything that is water. So if you remember correctly, earlier we had only surface points and underwater points. But the terrain classification, if I select here the classification color and I remove again everything that is other, I'm gonna scroll a little in my point cloud, maybe increase the size of my slice. This will give us a better look. If I scroll around here, we have a better look. I'm going to zoom in. You can see that we have 3 different water points colors. So in blue, you have the actual water surface. Grayish blue, we have the bottom of the water, and in orange we only have everything that is in between. So this can be fish or any artifacts in the water. So I'm just going to unselect it. So now I can also remove the whole surface. You'll have a better look here. If I remove the whole surface, I'm gonna end up with just the terrain, and we have a very good look here at the bottom of the water. So we have the ability to export this in whatever format we want. I'm gonna show you later how to export the point cloud, and we can then have an actual study of the terrain depending on what we want to do with it. Alright, so you could say this is pretty much it's pretty much done with the whole classification. But okay, so the colors are pretty nice, with whether it's elevation, classification, intensity. But like I said at the beginning, we also have an embedded camera on the YellowScan navigator, which means that during the flight, this camera was taking pictures, and I can just go to the colorization module here. I'm just gonna close this here. So I can just select the embedded camera, import my calibration profile, the calibration profile of the camera, and the CloudStation will automatically detect the folder containing all the images. And I can just click on colorize, and the CloudStation will use the image data and the LiDAR data and merge them to colorize all the points of the point cloud. Again, I've done this before, so I'm just going to show you the results. I'm going to close this panel here and show you the results of the colorization. And here you go. So here we have our geo-reference point cloud that is colorized with actual images from the actual flight, from the actual acquisition. And now you can see earlier we saw that these trees had different intensity than these, and with the color now you can see why. I can also merge the color of the images with the intensity and use this histogram here to make it better. Now we have a good look at all the colors with the intensity of the LiDAR. Alright, so now I'm gonna quickly go and show you everything else that you can do with the CloudStation. So we have the cut overlap feature. This feature allows you to remove redundant sections, or not actually remove, but best choose the best points in sections that overlap from different flight lines. I'm gonna give you a better example. So if I show the trajectory again here, let's say all the points acquired from this flight line have some overlap with all the points acquired from this flight line. But for final deliverables, sometimes we don't need overlap. So the overlap is necessary for all the processing beforehand, but in the case of final deliverables, sometimes we need to lighten our point cloud. So the cut overlap does this. You can just click here. There is no parameters to enter. Just click on cut overlap and it will basically clean your point cloud and select each time the best points to keep in sections that overlap from different flight lines. The other feature that has been added really recently is the smoothing algorithm. And this, along with the cut overlap, will allow you to smooth and lighten your point cloud. And you just have to select the strength, which is basically the aggressivity, how aggressive you want the smoothing to be. So this will impact more all the stairs or everything that has right angles or sharp edges. That's it. So once you're done, you can just go ahead to the export sidebar, and this is where you will create your final deliverables. All right, so now we have different export modes. The first thing is, of course, the point cloud export. So we have processed our point cloud since the beginning. We want to export it. We can export it as different LAS or LAS formats in 1.2 or 1.4. You can also export in text format if you want to. And then you can select the coordinate reference system you want to export in, and whether you want everything to be in one file or if you want to have one file per flight or one file per strip. And of course you have different filters you can select. In the ultimate bundle of the CloudStation, you can also export full waveform. This is the full waveform from the bathymetric LiDAR system. And of course you can select different strips. If you don't want to export all of your point cloud, you can select or unselect what you want or don't want. Now, the second thing you can export, since we've classified our points, we can export different digital models. So we have the surface model, the terrain model, or the height model. And of course, like always, you just select the coordinate reference system you want and click on export. The third thing that you can export if you have the ultimate bundle of the CloudStation is an orthophoto. So like we've colorized our point cloud using images, we can also generate a georeferenced orthophoto, and you can set different parameters here and generate your orthophoto. And the last thing that you can export are the exterior orientation of your camera, which are basically metadata of your images. You can either export them immediately in the EXIF or of your images, or you can export everything in a text file to, for example, import it on a third-party software later on. That's it for me. Thank you so much for watching and listening. If you have any other questions, don't hesitate to contact the YellowScan support, and I will see you soon. Bye bye.